state of the robot union. Where does research stand? Where is the commercial side of things? And how do we see Optimus evolve? As Tesla shareholders, I think we start thinking about Optimus as a potential wealth creation machine. That's certainly something Musk has been talking about a lot. We have been taking a rather careful approach here because it's a not proven product, and we haven't really seen anything, not from Tesla, but pretty much nobody has been able to show a commercial ready product. So we're kind of here like maybe like in GPT 1 or 2 or maybe 3. I mean, that's the question. But we're in this phase now where we see the potential. There's a lot of interesting work in academia. I think we can spend probably every week. There is an interesting live presentation, whether it's at Berkeley or Stanford here in the Bay Area, and then of course if you add the YouTube side of things, CMU, ETH Zurich, MIT, UW, those, just to mention a few. But there's really a lot of interesting work happening. Then there's companies. We have Physical Intelligence, certainly the most interesting company. We have the World Model companies, Fei Li's company, World Labs, and then Jan LeCun's company, and others. And then we have a lot of the actual commercial robot companies. Tesla is one of them, Figure, and then a lot of Chinese companies. So a lot of things happening in this space. Now, the way we see the state of the union of robotics, there's three important things we want to take away from this whole conversation. First, the whole space has been kickstarted when Elon Musk decided to bet the farm on robotics. And because he's been so successful in pretty much any other endeavor with hardware, people have jumped on the bandwagon in China and here. Second, there is real progress in the technology of robotics, and by the way, in the AI and the hardware side of robotics. So this is not just Elon Musk dreaming up something. There's real, actual, tangible progress. And third, we believe that the breakthrough, the GPT moment, will or can only happen when the data scale problem is solved, and it will be solved the same way Tesla has solved the FSD problem, which is through video data, through behavioral cloning from internet scale video data. Now, those are the three main things. We want to add one more thing, and that's generative video. We talk about this. This is maybe a little early right now, but it's in combination with what Tesla has done with FSD. The way we see Optimus evolve, and I think it's probably a good guess to bet on the whole robot space to evolve the same way, and that is behavioral cloning through internet scale video data with generative video attached to it. So that's the state of the union. Now, as far as timing is concerned, it could take some more time than maybe some people are thinking. We have almost no valuation for Optimus in our model for Tesla for that reason, because the timing is uncertain, and timing is a difficult one to gauge. The more we know, the less we know. In other words, the more presentations we hear from accomplished researchers, the more questions we actually have, because this is there's a lot. The force of the trend is in the right direction. Let's be clear. This is not a situation like maybe fusion or something like that. This is real. There's real progress being made in academia, real progress in the commercial companies, and also real progress on AI and also on the hardware side. I'm going to try to explain what I mean with that in more detail. This is not even on podcast. It's May 12th, 2026. This is Krimdelko. For the year, we're up 1.9%. The market is up 8%. We're underperformed by 6.1%. This is actually, we've been up the last few days, positive territory, the first time this year. So it's taken almost, not exactly, 1.5 quarters for us to get positive, and that's great news. It's always relief when you start getting into positive territory. I think we have a lot of good momentum now. We expect some really good numbers from Nvidia and repricing of the stock following all the other chip companies that have been going through the roof in the last couple of months. And for Tesla, we expect the same. We actually expect some very, very strong performance this year from both of our large investments because of the fundamentals. But let's talk about the actual, the state of the union of robotics. We said the big three things that matter for robotics. First, the whole space is on fire. And the reason the space is on fire is because Musk has launched Optimus a few years ago now. I don't remember exactly when it was. And that has really created this excitement. Now, that's not the only reason. I would say that's the reason why there's a lot of money and VC money going into the space, and also why China has decided to bet big on that space. The actual tangible progress that is being made is on the academic side. But what we mean with academic is not just theoretical research or something like that. It's also research in companies. The ability to evolve artificial intelligence in embodied agents, in other words, with robots, is real. So this is not just a pipe dream. It's real, and it's strong, and it's making progress. But like I said in the prelude, we believe that we're sort of maybe in the ChatGPT 2 area of robotics. So that means it's going to take a little bit longer than we thought. And most importantly, it's not going to, we're not ready yet. We're not ready to actually get excited about the space. We're not ready yet. The same way, ChatGPT 2 and 3 were exciting projects, and a lot of people were happy about it, but the big public, breakthrough didn't happen. It took more development and more technology, and I think we're in the same space. Most importantly, the breakthrough and the actual full-scale commercial deployment with real value creation, I think it's fair to assume that it will actually follow the same blueprint that the large language models followed, and that is internet scale data, pre-train, mid-train, fine-tune. I think that will happen with robots the same way it's happening now with agentic intelligence. So we'll have the pre-trained large-scale internet data, which is learning from video, behavioral cloning, like FSD and driving. The same approach will work here. And then we have the fine-tune. The mid-training is skill-based training. So that is, you have this large-scale internet, billions of hours of video, where you train a foundation model for robotics. Now, whether that happens with vision language action models, whether that happens with maybe more of a JEPA model, a la Jan LeCun, where you don't do autoregressive, but you do something more like correlative. I don't want to go into the weeds here for the technicalities, but just think about it this way: there is an architecture available to train a foundation model for real-world interaction, and that can be best trained from video data. The problem, of course, is you have to translate what you see in the video into actuator information for robots, and they have to be able also to predict the next scene and therefore act appropriately. I think what we've learned from large language models can be translated here, maybe not one-to-one, but there's a lot of learnings that we can use to approach this problem. I think, if we use the blueprint of the frontier labs, which is pre-train, mid-train, fine-tune. So pre-train, again, large scale, from video data, solve the morphology gap between humans and robots. By the way, this is just as a side note. The reason we have humanoid robots, it's not because the world is made for humans. Actually, the main reason we have humanoid robots is because we can learn from humans. And if we use a similar morphology, we can then have a much faster learning rate. So mid-train, if we use the mid-train approach in large language models, that is, there you start, you kind of bring the expertise into the model. So now you've pre-trained, you have this general knowledge, you know a little bit about everything, but now you have to, the mid-training would be you train on the large language side. It's you train the model about finance, you train the model about law, you train the model about coding. That's been very successfully applied, of course, by Claude. So Claude Code has been developed like that. So we have, again, pre-trained and mid-trained would be the learn how to code based on the coding data, and then fine-tuning would be the interaction with the user, in this case being a human, or the user could also be an agent. Now, if we translate this into the robot space, again, pre-trained would be the large-scale YouTube and other video data. Mid-trained would be then the skill-based learning. So here you train the robot to actually perform tasks in the factory. You train the robot to do maybe certain medical procedures. You train the robot to clean your house. So you actually give the robot the skills, and then the fine-tuning would be the interaction. So you want the robot to interact. This would be sort of, if we use the FSD equivalent of the car, where you want to make sure the car feels like a human. So again, in a humanoid robot, the question then is, okay, where is the robot being deployed? And if the robot is going to be deployed around humans, you want the robot to behave in a certain way, let's say more human-like. You certainly don't want the robot to hurt anybody, things like that. That would be the fine-tuning. One more thing we want to say, which is, I think people are underestimating, not the people in academia, I think, but generally people are not so sure about the value of generative models. And I think the generative models are actually a very, very powerful tool here, which is you can have, billions of hours of actual real video data from humans, learn in pre-training, but you can use also generated videos. So you can have a scene, let's say, where a robot cleans an apartment, and you can generate thousands, hundreds, or millions of trajectories where this apartment has different types of situations, and then you can also train the robot on those. You can basically solve the out-of-distribution problem by generating many, many scenarios, and therefore reduce the out-of-distribution space. Now, this particular problem of generative video, or let's call it the world model problem. So this is generate a digital twin of the real world, where a robot can learn through self-play using sort of an AlphaGo zero approach. Now that problem, in our opinion, has not been solved yet. I mean, there are some interesting approaches. Again, Fei Li is working on it. Yang Kun's working on it. And then a lot of commercial companies are working on it, maybe not directly. For example, Tesla is not specifically building a world model, but they, according to Ashok Elaswamy, the head of AI at Tesla, they've built generative models, let's say, for FSD, and we can see the same thing happening for Optimus. So the generative models have a bigger role to play. The problem with generative models is to generate videos that are physically realistic, that have consistency. So that's very important, that the person that walks on the road actually keeps walking on that same road, and that the same person with the same morphology, and that the physics of the road and the if it's wet and doesn't dry all of a sudden, and if it's not wet, then it's not all of a sudden wet, and things like that. So this robustness, so problems like that of consistency, of long-term horizon. Things like that still need to be panned out. So this is not fully solved, but I think there's definitely a lot of progress there, and we count that part of the stack as important for solving the robotics problem. So where does this all put us now as investors, right? We're invested in a company like Tesla. They, according to their CEO, most of the value of Tesla will be in Optimus. Now, if we fast forward, how is this like? Sometimes it's useful in the investment world also to think, okay, what is this going to look like once it's done? Okay, so for example, well, how is the cybercab network going to look like once it's all deployed? Well, the cybercab network, once it's all deployed, it's going to look something like this. You're going to have thousands of cabs circling around any kind of urban area in the world, and you're going to have 2-minute wait times max. It's going to be, and you're actually going to pay less if the wait time is more than 2 minutes. You're going to pay about $1 per mile, and transport will be, maybe kind of like bottled water. Like you're going to just consume it. It's not super cheap, but it's not something you care about, and it's something you're going to consume a lot, and it's going to be good for you to have access to all these, cyber cabs and other versions of transport in the future. The same will happen with logistics. The cyber truck will sort of have the mid-range, and then the semi will do the large-scale long-haul transport. We will have agentic workflows. So the same way if you use the Claude Code analogy here or Claude Cowork analogy, we will have the same in the real world. You'll have the networks of logistics. The cybercab network will be managed by Grok. Which car goes where, and then also which car is going to be charged at what point, and how it's going to be cleaned. And then at some point, of course, we're going to introduce Optimus here. Optimus will also help in this agentic workflows. So that's how this is going to look like. And the question with robotics, how's robotics going to look like? How's Optimus going to look like fully deployed? It's going to be, work as a service. You're going to hire robots to do work, stacking, shelves at Whole Foods, delivering food, welding on the water, things, space AI maintenance, like things like that will be executed by agents. There will be an agentic workflow. Again, Grok will manage this. So we'll have fully agentic robotic execution of work. I think before I go, certainly the most important part is then the sort of self-referential aspect of this. Once the robots start building other robots and start building the stack for the development of the next generation of robots, and we have this self-referential recursive system, I think that's for another episode. So to summarize, the state of the union of robotics is we are on the brink of a ChatGPT moment. We have ChatGPT moments, but not the ChatGPT 4. They're more like maybe 2 or 3. The ingredients are in place, and the model will be similar like the other frontier models of large language model space, which will be pre-training, large-scale internet data from video, mid-train expertise through either human data or video data and generative video, and then lastly, the fine-tuning and the agentic side of things, where we deploy this work as a service at scale in the real world, and then generate the kind of wealth that we think can be generated. Thank you.